Okay.
Good morning, everybody. Jacob? I got a busy period. All right. Cole, I saw you. Kaylee, are you here? Haley, excuse me.
Yes, I'm here.
Heidi?
I'm here.
Okay, Morgan, I saw Ella.
Here.
Noah?
Here.
Bryn?
Here.
Gus?
Here.
Zach?
Here.
Christian?
Here.
Nick? Here. Okay, Olivia? Noah? Dominic? Ari? Jack? Bryce? Jacob, I know is here. Darcy? Cora? And Kaya. Alrighty. Ella, did I send you an email with your test on it?
No, you didn't.
I just remembered I didn't do that. I am going to do that right now.
Okay, thank you.
Everybody else, you got one, correct?
Yes.
Okay. So excuse me, everybody, because I forgot to go into here and grab this and scan this, and I'll be right back. Sorry. I was like, okay, maybe I got like a B.
Especially when the community starts. So I'm just like, why would you want it now?
Alrighty. This, get this. Okay, Ella, I just sent it to you. Okay.
Yeah, I got it. Thank you.
Wow, already? Man, it's fast. All right, I'm gonna hand this to you guys, because I'm gonna go through the test, okay? So this is your opportunity to get points. Olivia? Oh, sorry, Cora. Everybody has one, right? Right here. All righty, I'm gonna go through this. See how successful I am. All right, I'm just gonna show you my key. I think that's the best way to do it, and if I have to show it to you differently. Bisters, do you see where it says key right here?
Yes.
Okay. So this was worth 1 point. You can see I wrote 1 right here. What I was looking for as an explanation is that you showed me that as you approached 4 from the left and from the right, you got 2 different values. So that limit did not exist, okay? Some people simply said it does not exist because the values are different as you approach from the left and the right. If you didn't give me those values, I took off 0.2 of a point. This one is determine whether the statement is true or false. It is false. And here's my example. Some people came up with other examples. Here is, I got a hole, and as you approach from the left and the right, you get 9 as the limit, but f of 3 is not 9. I think I have it as 4. Okay, everybody all right on that one? So if you had true, that would have been 1 point. The next page, this was worth 1 point. I could just strictly substitute. So I put 2 into here and got 8. Put 2 into here, got -12, plus 1, and I came up with a -3. Analytically, again, I can plug in 1 here, and I got a -2 on the bottom, and 1 plus 1 minus 2 was 0. This one was worth 3 points. It says, find the limit analytically. So what I did is I factored out an x squared, because that's the greatest common factor. I have x squared times the quantity x plus 2, so I simplify. And then I plugged in, I took the limit and plugged in a -2 and got 4. So that was the limit. Then I say state another function. So it had to be in function form. It could not be y, and it's another, so you can't use f. And you couldn't simply say x squared, because that's not a function. That's an expression. Am I that picky? Yeah. So it's got to be in function form, what the function is equal to, and where all the points are identical with f at all but one hint factor. So you couldn't say f of x equals x squared, you had to use some other letter. Then what is the graph of f? Well, it's like f of x equals x squared, except there's going to be a hole at -2, 4, because that doesn't exist. So if you didn't have that, if you had a parabola without a hole, I took off a point, because the whole thing is that there's a limit there, right? There is a value that doesn't exist. You can't use a -2 in there. So number 5 was worth 3 points. Number 6, this was, is that number 6? Is that correct? This one? So I have square roots, so I got to do the conjugate. So what I did is I did the conjugate first to simplify. I don't have to worry about any middle terms. So the square roots are eliminated, and I'm left with x plus delta x plus 2, which is what's inside both those radicals, minus what's in here, but it's got to be parentheses because I'm going to have to distribute this minus sign. And I got x plus delta x plus 2 minus x minus 2. You see that okay? So x minus x is 0, 2 minus 2 is 0, delta x plus 0 is delta x. That simplifies to 1. So now this is what I have. And some people left it as this, and I gave you credit for this. But that's the same as this, because you got 2 of them, right? And I can substitute 0 in for delta x because I don't have division by 0. So number 7 was worth 2 points. No, and then with the work. And so I first figured out I had to see if f of -1 exists. It does, and it's 11, and that's also the right-hand limit because you're approaching from the right. That's what greater than means. So then I figured out, okay, what's the limit as you approach from the left? Well, that's -1 because you get -3 plus 2. And that's not equal to what it is from the right. So the answer is no, because the limit doesn't exist. Number 8 was worth 1. Am I going too fast? I see people here saying no, because I have a tendency to go really, really, really fast. And I feel like I am. Here I said f of x is continuous in this interval since f of x is a polynomial. That's my first statement. Then I said f of -2, and I came up with 5 because it's 16 minus 8 minus 3, because when you square, it's positive. Then when I plug in a -1, I get 1 minus 2 minus 3, which was a -4. So that means 0 is bigger than a -4 and smaller than 5. So there exists a C in this interval. You can't say there exists a 0 in that interval. There's no 0 between -2 and -1. It's impossible. It's not the way the number line works. There's a value that makes y 0. And that's what I'm saying here, that when I plug it into there and get this y, it's going to give me that by VT. So that's what I was looking for. And there are 4 parts that I was looking for. If you miss one of those parts, I took 0.3 off. Number 9, very few people got this correct. So for some reason, some people got rid of the 3's. This is what I'm doing here. I currently have this limit. And this needs to be a 3. Well, how can I get that to be a 3? I can multiply that by 3/5. I can't do anything with this at all. This can't be touched because it's protected by the sign. But I can multiply this by 3/5 because that's just 5 times x. But then I'd have to multiply that by 3/5. That's what you're seeing right here. Because these 5 simplify, now it's a 3x. Now this is 1. And this is 3/5, and that's my answer. So that's kind of the work I needed to see. Here I factored. And since I'm able to do this, x equals 2 is removable. And x plus 3 is non-removable. And some people didn't write non-removable. They said it's an asymptote. That's not what I asked you. I asked you what type, give me the type of discontinuity. Number 11 was worth 1 point. So you have to approach 3 from the left. And if you approach 3 from the left, it goes to negative infinity. So I said, okay, I'm approaching from the left, it goes to negative infinity. And then I wrote it out. As x approaches 3 from the left, 1 is being divided by smaller and smaller values, causing unbounded y's. Unbounded means they're not headed to a number. Since 1 is positive and x minus 3 is negative, those y values are negative. And I said, okay, now I'm approaching from the right, that heads to positive infinity. And then I basically said the same thing. As x approaches 3 from the right, 1 is being divided by smaller values, causing unbounded y values. Since 1 is positive and x minus 3 is positive, those y values are positive. Boom, I'm done. So I try to take a look. Did you tell me that it was unbounded or going increasing? And they explain why it's negative and why it's positive. And that's what I was looking for when I broke down the points. Okay. So, Abisters. If you guys got any questions on the test, you can ask now. If you have specific questions, you can email me and I'll address them and look at the ones you have, okay? There were 14 points. The highest score was 13.5. So that's why you see that divided by 13.5. If you had a really good score on the first test, it didn't affect your grade. But you know we will have a third test, correct? And so that means some test is going to become involved. Does everybody follow that? So some of you moved from a C to an A+. That was really kind of cool. And I don't know what else, but if you got any particular comments, just give me a holler, okay? And I'll walk around now, and if you say, hey, what about this? I'll make the changes for the people that are in here, okay? All right. And I'm gonna start over here with Ari. Well, what I'm going to try to do is there's a way I can correct it on Google, okay? And write comments on it. I had to get a special stylus, which is coming Monday. Then you guys then I don't have to print anything off. I, with my iPad, can just sit there and correct it, the app. And then you got it. It'll be a lot faster because it really bothers me that it took me this long. I don't like it that I got to talk about it today. I'd rather talk about it yesterday. And I'd like to have it given to you right away, and then you can say, oh, I think I got an argument here. Well, let Olivia move it. jump, we didn't talk about, you haven't talked about limits, okay? I'm really picky about that, because you're gonna be tested on limits. And they and I want you to understand a jump occurs because the limits are there. That kind of makes sense? And I know this about me, okay? I have a different view than the other department. And their view and my view are both correct. I know that doesn't make sense. Well, here's the reason why. You probably noticed when you were freshmen, there were a lot of students in your math class, right? And then the people, for whatever reason, whittle themselves, and there are a lot less of you today than when you started when you were freshmen, okay? And so I upped the ante, and so you weren't asked to do that type of explanation because there were students that may not have been able to handle that explanation. Understand what I'm saying? So as a teacher, you decide what do you want to push, what don't you want to push. And I so adamant want you successful, and I know what they're going to ask you. That's why I'm leaving that out.
I had a question.
Oh, sorry.
I was wondering, like, what would you take 0.5 off?
Okay. So, do you explain to me, you do explain to me that it's something.
Yeah.
Okay? Okay, perfectly. Okay. But do you explain to me why they're negative and why they're positive?
Yeah, I do actually.
Okay, let me see this. Positive. Yep, let me try to think this stuff.
Okay.
So you got a pen.
Okay, cool, thank you.
So you got a pen,
Yeah, I got it.
you have a calculator.
I can grab one.
The quicker we do this, the more likely I'll remember. And you have to take, I suppose I could do this on my watch. See if it's faster. You are.
96.29. Yes.
Okay, so that'll change.
Yep.
If you don't see it change today, send me an email or text.
Okay.
And yeah, and if there's stuff, I've been getting emails from people that say, hey, I turned it in. Can you give me credit? Okay. Keep badgering me if I don't do that. It doesn't hurt my feelings. I literally get 100 emails a day now because of this stuff. And sometimes I lose the email that said, hey, I turned it in, because that's the difference between, because some of people are still turning them in, and I'm not anti that, but it means I forget. And I'm hoping we get away from sending me an email and doing it at Schoology. And I thought I'd never say that, but it's not good for you because there's two places for me to look. I suck at it. I am not a person that can multitask in any fashion. Okay? Does everybody understand that? Usually email was really pretty safe, but it's also when I get up in the morning and go, oh my God. And then I gotta decide what to keep. And I think probably the younger teachers are okay with that, but I'm starting to feel my age. And here's the other thing. And I know I'm talking to the people, so I should probably sit down and talk to you guys. I thought I did a poopy job yesterday. And so I'm going to try to give you a better idea of what's happening. And I think what happens, and I got to be really cognizant of this, I jumped, I think, too quickly to the symbolism and the algebraic manipulation. Okay? I really, really, really believe that. And so what I'm going to do is, first of all, you have an assignment that you're going to download a program called GeoGebra. Did any of you, did Mr. Karsh have you do any of that? Okay, if you go to the assignment, I have everything in there. I have the document I want you to fill out. I have a couple of videos explaining how to download it and how to use, you're going to get an application. And let me show you what it looks like. And then I'll share it with the other people. And then I'll go back and I'll try to re-explain myself. So I'm going to have to go back to here. And I'm going to share. What? Screen sharing has failed to start. Share. Share. What? You're not supposed to do that. Okay, let's, how can I get out of here? Okay, you guys see me, is that correct? The Bisters? I know the people here in class can see me. Bisters, can you see me? Bryn, can you see me? Okay.
Yeah, we can see you.
Okay, so let's try this again. Share screen. And I want to share a screen of this. Share. Do you see this now?
Yeah, we can see that.
Okay, so you guys can't see anything. Oh. So I'm going to get, you're going to see this in the video also, because sometimes people say, hey, I don't know how to do this. And then I ask them, well, did you see the video? Oh, were we supposed to watch a video? Yeah. So what I have here is I have a curve, okay, and I have two secant lines that are called S, and you'll get this. And this tells you the slope of those two secant lines. So S2, which is this blue one, has a slope of 3. And you can kind of see this. Here's a point that's on this graph, up 1, 2, 3 over 1, correct? And this other one's a lot flatter. It has a slope of 1.24, and that's the red one right here. Do you see that? And what I'm trying to do is I'm trying to figure out what the slope of the tangent line is at A. And you'll see that in the questions that I ask. And what I can do is I can move B. What I can do is this stands for how far apart. So this distance right here is the X distance, correct? Everybody have that? This is H. And so H is 1. And if you notice, if I make this smaller, that point B is getting closer to A. And these slopes are changing, aren't they? Correct? Remember, one was at 3. So the secant line of 2 is decreasing. And the slope of secant line 1 is increasing, right? Do you see that? Now there are 2 points moving because, let me move this. Come on, there you go. Let me move this. Sometimes they're stubborn. There we go. Okay. I got it a little crooked. So this distance This X distance here is H. This X distance here is H. Does everybody follow that? And I'm approaching both of these secant lines. And let's see if I could slide that down. And slide that down. And as I decrease H, points B and C are moving to A, correct? And look at the slopes of those two lines. They're getting closer and closer together, aren't they? And H is getting tiny. H is super tiny here, isn't it? Correct? And this point and this point are almost on top of A, right? And these, the blue line and the red line, are getting really close to each other. They're starting to approximate the tangent line. Does that make sense? So that's what your activity is about for Monday. And on your computer, you can manipulate that. And if you can play video games, doing this is nothing. Why do I struggle? Because I can't play video games. Everybody have that? But there, in the assignment, is the document I asked you to fill out, this program, but you got to download GeoGebra to open it up. Does everybody understand? You need that program to open up the application. And I have a video that tells you how to do that. Okay, everybody have that? Also, it might be, don't they have a place on your computer where you can get applications to put onto, download onto your desktop? I forgot what it's called. So yeah, it might be in self-service too. So if it's in self-service, that would save you, because I've asked them, and I never go to self-service because I don't know, it's self-service. It's kind of like filling, I remember when they used to fill up, come to your car and pump gas into your car and clean your window and fill the air in your tire and check your, you know, your radiator fluid and all that stuff. Well, now you got to do that yourself, right? So I'm not very good at self-service. That was a joke, but that was not good. All righty, does that kind of make sense? So there are videos, there's 2 videos, there's a document, and it's, and you should be able to type on it because it's just a doc, you know, and then you just submit it through Schoology, okay? All right. Any questions of Bisters? Are you okay with that? I can't see you, so Heidi, you give me a thumbs up. That's wonderful. All righty, so let's go back to this. Okay, I'm going to turn this back on. And I'm going to do a better job about what I was trying to talk about yesterday, okay? Does that make sense? And I want to go from a different point of view. So I actually slept well last night, but I was really, really worried about this. So I'm going to digress a little bit from the notes, okay? And so if you remember, the purpose of this is simply to find the slope of a tangent line. And Bryce, I'm going to ask you a really hard question, and you may not remember. You ready? Slope of a tangent line has 2 other names. Do you know what the 2 other names are?
Instantaneous rate and derivative.
Instantaneous rate and derivative, correct. And so we're going to look at finding our numerical derivatives, okay, using the limit process. All right. And I'm going to draw a picture. This is the function one over x. You may have seen this before. No, this is where x is greater than 0, right? The positive side, because I just don't want to do a negative. Okay? Right here, I have a point. So this point is 1, 1. Christian, are you seeing this okay?
Yeah.
And this is a tangent line. That got crooked at the end, okay? Now, the only thing I know about that tangent line is the slope is negative, correct? Does everybody agree that it's negative? If you go down and to the right, that's negative slope. If you go up and to the right, it's positive slope. So my answer should be negative. And Olivia, I use that because sometimes I make mistakes and I'll look at it and I'll say, that's not right because I got a positive answer and I know it should be negative. And that usually indicates to me I've screwed up. Okay? Now, right here, I have a point. That point is x, comma, f of x. It's any point on the graph, Jacob. If I wanted to, I could have put it here. Like this is probably 3 1/3. This is probably 1/2. Well, it's probably 2/3, 3/2, right? Because this is the reciprocal. Okay, you're okay with that, right? But I don't care what it is. And what I'm going to do is, if I look at this, this is a secant line because it passes through 2 points. And what I'm going to do is I'm going to slide that point in this direction and move it towards 1, towards the other point, 1, 1. Does that make sense? So down here, that's where x is, correct? Right? As I slide that point along that curve, that x is approaching 1 from the right. Would you agree? So I could write this, and the slope of this, of the red line, in fact, I'll write it in red, x approaches 1 from the right. That slope is going to be f of x minus 1 over x minus 1. Because that point is 1, this y minus that y, this x minus that x. Does everybody agree with that? Okay, I'm going to figure out what that limit is. Because as it moves and slide, you can see that this red line will start to tilt up, won't it? Correct? It'll start moving in that direction, right? In fact, I can go to my machine. Where is it? Give me a hint. Here's my machine. I'm going to put 1 divided by x. And I'm going to go to my menu. I'm going to go to my table to see if I can get an idea of what the slope of that tangent is. Now, I'm at 1. Well, what numbers are to the right of 1? Well, 1.1 is, correct? And I get that number, 0.909, right? And if I put 1 point, oh, excuse me, that's not what I want. I'm being done. I don't want this. I want this, parentheses, 1 divided by x minus 1 divided by parentheses, x minus 1. Sorry. That's the slope. This is f of x minus y, x minus x, correct? Are you okay with that now? That's what I want to look at. I'm sorry. So now I go to my table and I put in 1, I get error. I'm not shocked by that. I'm dividing, correct? By 1. So now I'm going to move close to 1. I'm going to put 1.1. I'm going to put in 1.01. Now, Olivia, just what I was talking before, I had a positive 0.909, right? And I knew I wanted slope, so I knew I had done something wrong. That's why I backed up, okay? And now I'm going to put in 1.001. Well, what do you think that limit is by looking in at those values? What am I approaching? -1. I'm thinking I'm going to get -1 as my answer. Let's approach from the other side. 0.9, 0.99, 0.999. Do these numbers look like I'm approaching -1 from the other side? I think the slope is a -1. Does that make sense to everybody? So now I'm going to come over here. Abisters, are we doing okay with that?
Yeah, we're doing okay.
Okay. So now what I'm going to do is I'm going to write the symbolic form for this. And I get the limit as x approaches 1 from the right of 1 over x minus 1 over x minus 1, correct? Does everybody see where 1 over x came from? So no radical sign, no factoring, I got to get common denominator, right? The common denominator is x, isn't it? So that means I'm going to have 1 over x minus x over x over x minus 1. Make sure you tell me if there's some algebra you're not seeing. This is 1 minus x over x divided by x minus 1. Okay, Darcy? So now what does this mean? That means I have a fraction and I can multiply by the reciprocal. Ah, Jack, these look a lot the same. You know what I do? Not yet, not yet, okay? They look a lot the same, but they're reversed, aren't they? So I plug in numbers. Oh, I'll plug in 3. 1 minus 3, 3 minus 1. 1 minus 4, 4 minus 1. 1 minus 5, 5 minus 1. What are those answers? They're what? Opposites, aren't they? Didn't I get a -2 here, a +2? A -3, a +3? So what do I get when I divide opposites? What do I get when I take a -3 divided by 3, a -4 divided by 4, a -5 divided by 5? Right, and in fact, you could factor out a -1 and you'd get x minus 1 on top, or minus x plus 1. But a lot of times if I see that they're just reversed by a minus sign, I automatically go to a -1. But you're right, I'm able to bring out my red pen. And put a -1 here, correct? So now I have this as my limit. Limit as I approach 1 from the right of -1 over x. Does everybody agree with that? And can I plug in 1 here and not worry about dividing by 0? And do I get a -1? Now my argument is, if I would approach that from the left, the only thing that would change is I would have a minus sign here, correct? But I'd still have this, correct? I still would have to do this algebra, correct? And I would still get a -1. How do I know that? This thing's continuous, correct? Right? Would everybody agree with that? And if you can take a look here, the only thing that would change, this would still be the same, but I would just put a minus sign in here, right? And you can see when I typed it in the table, I got the same value. Everybody with me on that? So I'm now going to come up with a different function, all right? And I'm going to come up with this. I'm going to come up with a negative x squared plus 3. And if I draw it, it looks like that, correct? Did everybody agree? And so I'm going to draw that. And I'm going to plug this point in here. X is going to be a -1. So, Kaya, a -1 comma what? How do I figure out that y? I plug it into f, don't I? Because f computes my y's. So I plug a -1 in there, I square it, I get a +1, and then I make it negative and becomes a -1 again, and then I add 3, right? Isn't that what it's telling me to do? And Jacob, if I do that, what do I get? I don't think so. I get I do the squaring first, right? This is, you're really multiplying by a -1 here, right? So I square -1 first, it becomes positive, and then I multiply by this coefficient, a -1, and becomes a -1 again. Right, 2. And this point right here has got to be 3, right? I can't get a number 4 because I can't be higher than that point. So the slope of this tangent line looks like this. I know it's positive, correct? Olivia, I could do the same thing. I could come now, go to my table, and I want to pick numbers that are really close to a -1. So I'm going to put a negative 0.9, a negative 0.99, a negative 0.999, and then I'm going to put a 1.1, 1.01, and 1.001. And what do I think it's approaching? 2. I think it's got a slope of 2. Because you can see I'm really close to 2 here, and I'm really close to 2 here. I'm guessing 2. Now I can't use this if on Kruger's quizzes or tests to see if it makes sense. You understand? If I ask you, okay, compute it using the limit process, well, then we got to use the limit process. So here's the limit process. The limit is this. What am I approaching? I'm approaching a negative 1. And it's going to be f of x, right? Because this graph is f of x. And I'm anywhere. I'll pick here. This point right here is x comma f of x, right? No, I just picked here. I could have picked here. I could have picked here. It's kind of dumb. It's a long ways to walk over to a negative 1 when you're on the other side of 0. And I don't like walking a lot. So this is going to be f of x minus 2. Why did I choose 2? Because that's my y value, isn't it? Right? Over x minus a negative 1. Why do I choose a negative 1? That's my x value. And somebody yesterday says it's x2 minus x1. Are we doing okay on that? You see people shaking their heads. So now I'm going to write the limit as x approaches negative 1. And I'm going to have a negative x squared plus 3 minus 2 over x plus 1. I can't substitute because I get 0, correct? So I either going to simplify fractions, multiply by the conjugate, or factor. Which of those 3 do you think it's going to be here? Factor. Well, I got a little work to do, don't I? Okay. So this is going to be a negative x squared plus 1 over x plus 1. Would you agree with that, Bryce? Bryce, I can do this. 1 minus x squared over x plus 1. Bryce, does that look okay? Are those conjugates? Is that a perfect square? Is that a perfect square? Am I subtracting? So this is a product of conjugates, correct? Does everybody see how I did that? 1 times 1 is 1. X times x is x squared. So what do the conjugates look like, Bryce?
Negative x plus 1, and then x minus 1.
Could I say this? 1 minus x and 1 plus x? 1 times 1 is 1. The inner and the outers will be opposite. And minus sign, and x times x is x squared. Are we okay with that? Are these the same? 1 plus x is not the same as x plus 1? They are, aren't they? 1 plus 2 is the same as 2 plus 1? Gone, right? Okay. So now I'm going to come over here and have the limit as x approaches minus 1 of 1 minus x. Can I plug a negative 1 in there and not worry about division of 0? What is 1 minus a negative 1? 2, which is what I thought was going to be the case. Is that making sense? Cole, is that helpful?
Yeah, that helps a little bit.
Okay, a lot better than yesterday, Christian?
Yeah.
Okay, because I went a different way. I talked about H and delta X. It doesn't mean I'm not going to go that way, but I really thought about it a lot last night. And I think this is a lot simpler way to do it to begin with. This gives me my numerical tangent line, okay? It gives me what I call a constant, a number. Now, let's go back to the notes. Wherever I put them. These are not them. Make sure you guys grab the 2.2 notes before you leave, and I have them in the office, okay? So stop me in 5 minutes and I will go get them. Okay, everybody have that? So I want to do example 1 all over again. Okay? And I had done all this stuff, right? And scared the bejeebers out of you, right? I know I did. Okay? So it says, find the slope of the tangent line. So I'm going to use this idea. It's the limit as x approaches 3. Do you see where I get 3? Noah Jensen, do you know where I get 3?
I think so. Isn't that because it's the X value?
Yeah, it's the x value right here. Perfect. Perfect. So now I'm going to write my slope formula. And so it's going to be x minus 3 because I'm on some point here, x comma f of x. Okay, Noah? And so it's this x value minus the 3, this x value. Noah Jensen, okay?
Yep.
Okay, now on top here, I'm going to have x squared. Noah Jensen, do you know where x squared came from?
That's what f of x is.
Yes, excellent. Now I'm going to ask you one hard question, Noah. Minus what?
9.
Because that's the
Y.
perfect. Everybody see that? Now, I go through my 3 choices. I go through my 4 choices. I can't sub, right? Right, Darcy? I can't plug a 3 in there. So am I going to multiply by conjugates? Am I going to simplify a fraction? Am I going to factor? What do you think? Factor. And so this x squared minus 9 becomes over red pen, bam, right? So now what I can do is rather than take the limit of this, I can take the limit as x approaches 3 of x plus 3, which is a nice, easy problem. And I have a slope of what? Slope of 6. A lot easier. My God, what was the crazy man thinking about yesterday? He was nuts. I couldn't believe how well I slept last night. You know why? Because I worried the bejeebers about you guys because I had done such a lousy job. Now, I got 30 seconds and then I'm going to get the notes for thing. I'm not done with these, so it doesn't look like we're going to have a quiz next Wednesday. You're going to see some adjustments, okay? I think Wednesday is going to be a work day. I'm kind of leaning towards that, okay? Maybe a little bit of notes. Okay. Now, this tangent line is a line, correct? Right? And I know it has a slope of 6, correct? What's the equation of that line? Heidi. What two things does every line have to have? I'm going to say this over and over and over. For a line, what two things do you need?
Do you need 2 points?
You could have 2 points, but you can get by with 1 point because I got 1 point here. I just need 1 point and what?
And the slope?
The slope, which I have, correct? So the equation, and you're going to see this notation, it's a line, and I'm going to put a little t right here because it's what kind of line? Heidi. What do you suppose the t stands for?
Tangent?
Tangent line. It's a tangent line. I know it has a slope of 6, correct?
Mm-hmm.
So I do not use slope-intercept form, Bryce. I'm not anti-slope-intercept form. I'm into one, always getting the right answer and doing it quickly, right? I think you guys have figured that out. That's pretty huge 2 ideas in this class, right? So this is what I do. X minus 3 plus 9. Where did there was my point, right, Heidi?
Mm-hmm.
Now, Heidi, I am totally worried like all the time. So what I do is I plug 3 in here and I say, do I get 9 as my answer? And the answer would be, if I plug 3 in here, I take 3 minus 3 times 6 plus 9. Will I get 9? What's 3 minus,
Mm-hmm.
what's 3 minus 3?
0,
0. What's 6 times 0?
0.
0. It's like 0 is the killer of all numbers, you know, right?
Mm-hmm.
It's the great eliminator. And so when I take 0 plus 9, I get 9, correct?
Mm-hmm.
That's as far as I go for work. I do not go and find the y-intercept unless they ask me to. Does everybody understand that? I'm done. It's perfect. Because this is what's going to happen, Darcy. You'll have this. And then you'll write 6x. And then you'll take 6 times a minus 3 and write plus 3. And then add 9 and get 12. And you'll say 6x plus 12, and I have to mark it all wrong, even though you were right here. Because you did an arithmetic mistake, which happens to all of us. You understand that? So I stop right here. All right, here, find the slope of, let's do this one. Oh, that's probably a good idea. So I'm going to pause here and go get notes for the class people. And the people that are in the BIS, this is the notes that I'll be giving Monday, Tuesday. And so you'll have them. And I will also have, probably on Tuesday, the 2, 3 notes, which I can give you guys on Thursday. How's that sound? Thursday, Friday. Because I got to think ahead like that. Okay.
Sophia has this hour.
Morgan, are you still there?
Yes,
How you doing?
I'm good. How are you?
I am feeling better now because I was very nervous. Am I making you nervous?
No?
No, we're gonna find the slope with this as our function, right? We skip this one. You ready? And you're gonna help me out, Morgan.
Oh, gosh.
Limit as x approaches what?
2?
Ooh, perfect, because that's my x, correct?
Yes.
Okay, so then I have the slope formula, right?
Mm-hmm.
X minus what?
1? I don't know.
That's 1 is a y value.
2?
2, right? Isn't this is some x comma f of x, some point on this line, right?
Mm-hmm.
And then it's going to be f of x minus what? In the y value.
1?
1, perfect. You did it perfectly. Okay, everybody agree? So now, Morgan, the people over here are saying you're doing an awesome job, by the way. They're smiling underneath their masks. So I'm going to get rid of this f of x. What am I going to replace it with?
1?
Nope. What's the name of f of x? It was given a name.
I don't know.
And it says, find the slope of the tangent line of f of x equals 2x minus 3 at the point 2, comma 1.
Oh, 2x minus 3.
Yeah, 2x minus 3. So we're going to do a little bit of simplification. Well, let's just cross this out for a second. That's what we got to fix, right? I can't plug a 2 into there. So I'm going to factor, right? Would you agree?
Yes.
And I have 2x minus 4 over x minus 2. Would you agree?
Yes.
What can I factor out at the top? What's in 2x minus 4?
You can take a 2 out.
You take a 2 out. And I get what?
2 times x minus 2.
Like this?
Yeah.
Do I get to use a red pen?
Yes.
Bam! Did that hurt your ears?
No.
Okay. So now my limit is this. The limit as x approaches 2 of 2, correct?
Do you have?
What's the answer to that?
2?
2. Now, this equation, 2x minus 3, that's a line, isn't it?
Mm-hmm.
And the slope of this line is 2. Correct? Remember yesterday I said it has no concavity? It looks like this. Right? That's what that line looks like. The tangent line to a line, Bryce, is the only one that touches this line at every single point. This Red line is the tangent line. They do what we call, Darcy, in geometry, coincide. Poof! Like this, side by side. A line is its own tangent line. So if I know the slope of the line, I know the slope of the tangent line. Boom. Alrighty, see you guys tomorrow. Oh, not tomorrow, Monday. So there will be no quiz on Wednesday. I'll make those changes. Okay, guaranteed. Everybody got that?
We look at my test grade through them.
Oh yeah, I gotta change it to a 96. I'll do that